Refactoring changes a software's internal structure to make it easier to understand and cheaper to modify, while leaving its observable behavior unchanged. Working code isn't always healthy code. Left unchecked, its internal structure decays, meaning new requirements become much more difficult to implement without introducing errors. Kent Beck introduced the two hats paradigm, a strict separation of concerns. You never add functionality and refactor simultaneously. When wearing the feature hat, you add capabilities but don't touch existing architecture. Swapping to the refactoring hat, you restructure code but never add features. Building software solely for machine execution often results in a rigid monolith. Restructuring that monolith through a rhythm of small, disciplined steps provides a path to sustain engineering velocity over the long term. Take this block of procedural JavaScript. It's a dense function used by a theatrical company to calculate costs and print billing statements for their customers. The business needs two updates. They want billing statements rendered in HTML, and they plan to add new performance categories, like historicals, to their repertoire. Fulfilling these requests inside the current structure requires copying the entire function to write an HTML variant, and then adding new conditional logic for the pricing rules. This duplication makes future maintenance twice as difficult. Before altering any code, we establish a prerequisite, a fast, self-checking test suite. These tests verify the exact output of the original function. They act as a continuous bug detector, allowing us to change the architecture while ensuring we haven't introduced any regressions. Target the switch statement. Using extract function, we move this logic into a distinct routine, amount for. We pass disconnected temporary variables as parameters. With the extraction complete, we hit the rhythm of refactoring: compile, test, and commit. By isolating this calculation and naming it explicitly, we offload the effort of remembering what it does. The code now describes its own purpose. The temporary variable play is still cluttering the function. Computed on every loop iteration, it makes extractions difficult. We use replace temp with query to remove it, calling a new function to directly query the play record wherever needed. This forces the loop to execute the lookup function 3 times per iteration instead of once. In modern computing, the time cost of repeating a simple lookup is usually negligible. The true benefit here is architectural mobility. Focus on architectural clarity first. Only after the structure is clean can you accurately identify and address the small percentage of code that actually limits performance. We can now tackle the first feature request, generating an HTML statement. We apply the split phase pattern, dividing the program into calculation and formatting. In phase 1, pricing logic packages results into an intermediate data structure. In phase 2, this data object passes into rendering functions, outputting plain text and HTML. Decoupling the math from the presentation ensures that changes to the pricing logic will automatically update both rendering formats without requiring duplicate chunkas. The second requirement is to add new play categories, such as historicals and pastorals. Adding these requires inserting new cases, forcing you to locate every scattered conditional block. We use polymorphism to remove conditionals, creating a performance calculator superclass for common logic. We then move specific variations into tragedy calculator and comedy calculator subclasses. The system supports new play types through extension. Adding a new category only requires writing a new subclass, leaving the existing calculation logic completely untouched. Here is the difference between the starting state and the final result. On the left, the logic is a single tangled node. On the right, it is a pipeline of separated, manageable components. The final refactored codebase contains more lines of code and more files than the original monolith. This expansion is a trade-off for clarity. By enforcing strict boundaries and using explicit names, the cognitive footprint required to understand any single part of the code is smaller. The code now communicates its intent. A developer can modify specific logic without having to understand every other part of the system simultaneously. Software projects often start fast, but grind to a halt as technical debt makes the system too complex. Disciplined refactoring takes a small time investment, but prevents this decay, allowing development to continue at a steady pace. Refactoring ensures the codebase remains cheap to modify, providing the structural health needed for sustained velocity. Writing logic that a computer can execute is easy. Engineering is the discipline of writing code that the next human can understand. To keep code healthy, respect the two hats, take tiny steps, and always leave the code cleaner than you found.